The final objective for the day, explicit formulas. So far we have been able to learn about sequences in general, some terminology for sequences, and then being able to determine whether the sequence is arithmetic or geometric. Remember, arithmetic have a common difference, meaning they're adding the common difference. Geometric is a common ratio, meaning they're multiplying. Ratio is multiplying. As you can see, two things should jump out at you right away for the given arithmetic sequence explicit formula right here, and then geometric right here. The arithmetic conveniently has a D in purple, and the geometric has an R in red, meaning D for difference for arithmetic, R for ratio, geometric. It's pretty straightforward, but if you have a formula ahead of you, if you're looking at a formula, if a test gives you just a formula and wants you to determine is it arithmetic or geometric, that is always my clue that I use. Does it have a D or an R? And the other thing that jumps out is the addition sign. Is it being added? Is there terms that are being added to each other? Or are they multiplying? Obviously adding would be arithmetic, multiplying would be geometric. Alright, explicit formulas. These formulas are used to find the what's called nth term of any sequence. Meaning, if I want to find the 50th term, if I want to find the 55th or the 100th term, these formulas will do that for me. To introduce this topic, we discussed briefly how the history of math, people used to have to just count numbers, and that would take a whole long time. So these are the formulas, these explicit formulas, after people were able to find patterns. They derived these in order to find large amounts of numbers, so it wouldn't take a long time. Now, let's begin with arithmetic sequence, the formula on the left. A sub n, meaning this should look familiar. This is a function, like any function. We do f of x, we do h of x, h of z, whatever it might be. A sub n is just denoting that this is the function. If I put an input into the right side of the equation, it'll spit out an output, same as we've been working. So a sub n will always be there in an explicit formula. The two that will change are my a sub 1 and d. That's what I've labeled down here. A sub 1 and d. A sub 1 will always equal the first term in the sequence. A sub 1 will change and d will change, like I just said. D equals the common difference. So you are going to have to do some math to actually find out the common difference, but we just practiced that, so that shouldn't be too difficult now. These are the only two things that will change. This is up here again, this is the generic or the just explicit formula for any given arithmetic sequence, but each sequence has its own based off of its first term and based off the common difference, and we'll talk about that in just a second. Now, same thing for geometric over here. A sub 1 is still the first term listed, but R, instead of common difference, is common ratio. So far, so good, I hope. That's it. Those are the only two things that will change in all of these explicit formulas. Now, let's scroll down to continue this objective. How to derive, because this will be something you'll have to do in just a little bit, how to derive a given, or how to derive the explicit formula if given in an arithmetic sequence. So, if I were to do this, I have the sequence -9, -2, 5, 12, and 19. I have to do, so let me model this for you. If I were to think about this sequence, I would have to come up with two pieces of information. Like I said earlier, a sub 1 changes and d changes. A sub 1, remember, is the first term, and it's going to be different for every sequence. The first term in this case is -9. Now the difference, I'm going to have to do some math. Remember how I talked about it in a previous video? I'm going to do, there's two options. In this case, I'm telling you that it's arithmetic. So I know that the difference will be adding. I'm going to add a number to -9 to get to -2. In order to find that, remember I take the second number minus the first number. So in this case, they're both negative. -2 minus a -9 equals +7. So I have my two pieces of information that I need to derive my explicit formula for this given arithmetic sequence. I just put them into, I replace a sub 1 up here with 9, and I replace d with 7. That's it. That's going to give me my formula. So I get a sub n equals my a sub 1, which is -9, plus, we're adding. If this 7 was negative, then it would be subtracting, but plus 7 times n minus 1. This is the explicit formula for this given sequence. Now, be considering, what do you think would happen? This would allow me to find any term of the sequence. If I wanted to find the 50th term, where do you think I would put 50 into this new equation or formula that I just derived? There's only one variable, so be thinking about that. The same thing for geometric over here. Geometric, I have 2, 4, 8, 16, 32. I still have to identify my a sub 1. It's the first term. In this case, the first term is 2. That is my a sub 1. My ratio now, I need ratio for geometric because we're multiplying. Again, this is pretty easy to consider these numbers, but I take the the second term of 4 divided by the first term, 2, and that gives me 4 divided by 2 is 2. To double check, you could try 8 divided by 4. 8 divided by 4 is also 2. So I have both pieces of information. I replace a sub 1 up here with 2, and I replace r with 2. Happens to be the same thing in this case. So I have a sub n equals a sub 1, which is 2, times 2 raised to the n minus 1. And I'm done. That is the explicit formula for my geometric sequence.